Hi. So here we are again. We've discussed three-phase power, single-phase power, our nominal voltages, 24 volts, 120 volts, 208, 230, and 480 volts. Those are the voltages, for the most part, that we work with in the HVAC field. You may come across something 277. That's usually for industrial lighting. So don't worry about that. Our our current is supplied by the power company. In this area, it's Baltimore Gas and Electric. That power comes in through the power poles from the power plant, through the transformer, and down to your electric meter. From your electric meter, it goes into your house and to your panel box, your circuit breaker box. And we're going to discuss the circuit breaker box today and the circuit breakers that go in there. So here is a typical circuit breaker box. Um, they come in different sizes. This is about midway. You'll see smaller ones. You may see larger ones. Typically, in a residential application, this would be recessed in the wall, and you would only see the outside. Okay, you wouldn't see the inside. You would definitely wouldn't see any of this. Okay, so let's open it up and see what's inside. Inside, we have our breakers. Most of these in here are single pole breakers. And the single pole breakers are used for 120 volts. 120 volts only. And we're going to show you how that works when we take the cover off. Yes, we are. Let me state this right now. Do not, under any circumstances, take the cover off the panel box in your home. At this point in your career, at this point in your training, you do not have enough training or experience to take that cover off. If you do, you are opening yourself to serious injury and or death. I'm dead serious about this. Okay? Do not go into your panel box. You do not have the experience to do this. All right? The power to this one right now is shut off. I've turned it off at the feed. So this panel box here is safe. All right? So, again, these are single pole breakers, usually used for 120 volts. In your house, they would be used for your light switches, your outlets. Pretty much that's it. Each circuit would probably serve a room or a couple of rooms. You might have one of these that would take care of all the outlets and the overhead light in your living room. You might have another one that would supply the power to all the appliances in your kitchen outside of your stove or your dryer, if that's where your stove and dryer are. All your 120 volt circuits. Let's see. You might have one that takes care of the two back bedrooms in your house, and another one that takes care of the two front bedrooms in your house. You might have one that services the garage or down in the basement. So each one of these is going to service a complete circuit. Now, when you get up to the two pole breakers, these are 240. Okay, 240 volts. They're usually dedicated circuits to a dedicated appliance or a piece of equipment. Your hot water heater, your electric dryer, your electric stove, and of course your air conditioning system. Also, if you have a heat pump, that would usually be 240 volts also. So, as you can see the difference in size, these actually take up two spaces, and we're going to show you why that is here and when we go to another panel box I have that has, you can see a little bit more of the back and how the power comes in. So this is fairly old. It's dusty and dirty. As you can't see here, but along each side, there are numbers, odd numbers on one side, or excuse me, odd numbers on one side, even numbers on another. Those numbers correspond to the labels over on this side. So you can label what each one of these breakers service. In this particular panel box, This top one on this side, number 1, services a time clock. Number 5 services a spray booth light, as does number 7. Um, on this side over here, this one services the lights in the bathroom. Um, this one down here services the hot water heater. Okay, so, and when you come back, this little red one right here, it services our condensing unit sitting all the way over there in the corner. But right now, all the power to this is off, so there's no power to that, and just to be doubly safe, I got the power off here. So, let's go ahead and take this panel box off, or excuse me, the cover to the panel box. Never get into a piece of equipment like this unless you have proper tools, okay? You don't want to use a tool that's a screwdriver that's too small or that's too big, all right? The proper tool for the proper job makes it a lot simpler. Right now, pretty much any application is going to have a tool dedicated to it, okay? Don't use a pair of Kleins to hammer in a nail, all right? Don't use a screwdriver to cut a hole in a piece of ductwork. I've done it. All right, so as we're taking the cover off of this, these things are heavy. They're made of steel. All right, the larger ones are heavier still. So you want to brace this down at the bottom, unscrew it. Doesn't take much with these screws. Okay, you want to be careful. Remember, you're bracing it down here. Take the cover off, place it down, and you're good to go. All right, so here's the inside of our panel box. Our power supply coming from the electric meter comes in. As you can see, there's 3 wires. There's a white, a black, and a red. Okay? The black and the red are hot conductors. They are each 120 volts. Your white is your neutral. 120 volts for each leg. That adds up to 240, and that's how we get our 240. Residential systems, residential applications are supplied with single phase 240 volts. Yes, that's a question on your quiz, on your test. Your house residential systems are supplied with 240 volt single phase electricity. Okay, so as you can see, one side is 120, one side is 120. We're going to take one of the breakers off here. As I said, I've already got the power turned off to this, so it's safe. We're going to open this up. These things just pop off. This thing's been in there a while. Okay, so as you can see, it's definitely been in there a while. So, yeah. All right. So, as you can see, our power comes down. Is attached to that lug. That lug is screwed into that bar that comes down. It feeds power to this side. That one does the same on this side. These two here pull power from both of these lugs in the middle, and I will show you on the other one how that works. So, power comes in. When this breaker is turned on, it allows the power to go through, comes through this wire, and goes to whatever that is, whatever that's supplied. So we're going to pop that in. As you can see, you have this clamp here, hits onto that plastic. This point here clips onto the lug. All right, line that up. Boom, boom. Push that in, and you're good to go. Give it a little tap, and you're good to go. All right. On is towards the middle. Off is towards the outside. On is in the middle. Off is outside. There's also a second position or a third position, and that's called tripped. When your breaker is tripped, it's about halfway between on and off. You cannot, or you should not, if you do, try to force it, it'll break it. Do not go from the tripped position to the on position. You'll break the circuit breaker. You'll break something inside. If it's in the tripped position, you must go all the way to the off and then reset it. A little sidebar here. If you come onto a system where the circuit breaker for that piece of equipment has been tripped, use your ohm meter to find out if it's shorted to ground first before you reset it in the panel box. If you just go in and reset that circuit breaker and something is shorted in that unit, you're liable to create a dangerous situation. That might not be why this tripped. It could have been the compressor motor could be seized up, a fan motor could be seized up, the outdoor coil could be very, very dirty, and the compressor had such a load on it that it tripped the breaker that way. That's fine. But before you try that, always use your ohm meter to determine whether or not that breaker was tripped because of a short to ground. It could save your life or somebody you care about. Okay, so panel box. Wires coming in, or excuse me, actually wires going out, goes to the circuit, then comes back and comes back to neutral. Okay, all these colored wires go out onto the circuit, and then they come back on white, and they attach to these neutral bars, okay, or buzz bars. And in a nutshell, that is a panel box. We'll go into the individual breakers here in a minute. I will show you what the inside looks like.